And we're live. Welcome to our episode of Business Focus Live with me, John, where we discuss different topics that help you achieve your business goals. So if you're new to this channel, don't forget to subscribe and let's get started. Let's see if there's a who's online today. Let's see. Say hello first to everyone. See if everyone's here. Let's wait. Anyway, while waiting for the rest to join in. So today's topic will be continuing our discussion on linear programming. So before we proceed, start with our intro. And we're back. So while waiting for the rest to join the live stream today, so I want to discuss a few things first before we proceed with our main topic. As I mentioned, regarding the quiz 2 result. Forget that one. So I've already finished checking your quiz 2 results. So I'll be posting the result tomorrow. I'll send everyone a link. I'll post it by 1 p.m. tomorrow. So you have a short window until 3 p.m. to view the result. So I have included the quiz 1 result as well as your quiz 2. Included is the incentives for the different activities that we have done up to this point. So if you have any questions, you can email me afterwards. Next part is regarding your quiz 3. So depending on how our live stream today goes, our tentative schedule is to have it after the Holy Week, which is sometime next week. If that changes, I'll update everyone. So our conference we mentioned for quiz 3 will still be all about linear programming. So the topics that we discussed last time and today will be included. Okay, and next is we'll be discussing our assignment, as I mentioned. For those who have already started collecting data or was able to collect data before the lockdown, you can continue and finish the paper. Now, for those groups that were not able to start collecting during the lockdown, you're given an alternative meaning a case study instead. So you just have to answer that and follow the format from your case analysis. And it should be submitted by end of semester. And finally, from your project, assuming whenever classes resumes, whether that's next week or whenever that is, we'll go straight to the project presentation. Now, just to think ahead in a worst case scenario, in the event that there will be no more classes or if it will be extended, whatever the case may be, if a worst case scenario that there will be no more classes held, the requirement will be just to submit the project paper. So it's very important that you answer the case project very well. And we'll wait and see what happens after the scheduled lifting of the lockdown, which is next week. If it's extended, which is seeming more likely, we'll have to wait and see. So to continue with our main topic, so as I mentioned, just to go over some of the key details of linear programming. So linear programming is a mathematical tool for decision makers to help them make better decisions. in terms of identifying an objective, identifying your limitations or constraints, and based on that, come up with the best possible outcome or the optimal solution. So I've sent everyone different problems to try to solve, and we'll try to answer it here online during the live stream. So if you have any questions, you feel free to send your message or post your questions, and I'll get back to you later on. So let's start first with our first problem. So let's just do the Excel. Okay, not this one. There you go. There you go. So for our first problem, this is about Kelson Sporting Equipment. So they're a manufacturing firm that sells two types of gloves, primarily regular and catcher's model. So it mentions here that the company has a production hours for the different processes. So to produce a glove, it goes to three different processes, from cutting and sewing, finishing, and packaging and shipping. So that's one of their limitations, that for every process it takes a certain number of hours. Like in this case, for regular, it takes about an hour for cutting and sewing, while for catcher's model, it takes about an hour and a half. And for finishing, it's 1/2 and 1/3. For packaging and shipping, it's 1/8 and 1/4. And as mentioned in the problem, that for each process, there's a maximum number of hours. So for cutting and sewing, it's only 900 hours. For finishing, it's 300 hours. And for packaging and shipping, it's 100 hours. And as you can see here, that the profit per unit is mentioned here. So for regular model, for each regular model you sell, you generate $5, and for catcher, it's $8. So we need to translate this and create a mathematical equation, mathematical model, before we can proceed with spreadsheet modeling and use Excel software. So to do that, we need to identify first the objectives. Before we do that, we need to identify the decision variables, meaning what are the factors that can affect your objectives and constraints. So for our decision variables, primarily to maximize profit, they make profit by selling their product, which is the regular and catcher's model. So let's assign variables for the different models. For regular, let's use R. And then for catcher, let's use C. So once you've identified the decision variables, we'll try to identify the objective. Since profit was mentioned in the problem, typically when you associate profit, you want to maximize profitability. So how do we maximize profit? To sell as many regular and catcher's glove. So we illustrate that by stating to maximize profit, we sell as many regular and catcher's models. So that would be 5R for regular plus 8C for catcher's model. Now next is identifying your different constraints. Now in this particular problem, it's already illustrated in the table below. So you can see the constraints primarily pertains to the different process, from cutting, sewing, finishing, packaging, and shipping. So technically there are only 3 here. But is it only 3? We'll find out. So for our first constraint, primarily is the cutting and sewing. So to label that, extend this one. Okay. So to create the equation for that one, so that would be 1R. So 1 hour of cutting and sewing for regular model plus 1 1/2 C. So that's cutting and sewing for catcher's model. Or in this case, it's 3/2. They're the same. So for our second constraint, that would be for finishing. So that's 1/2 R plus 1/3 C. And then for the third constraint, it's packaging and shipping, 1/8 R plus 1/4 C. So that's only on the left-hand side. Now, if you notice, in a linear programming equation, there's a left-hand side, there's an inequality, and the right-hand side. Now, based on the problem provided that cannot exceed the maximum production hours, so we'll use the inequality of less than equal. So it applies to all 3. So that's why you can see here, it states that it's less than equal to all 3. And then you can see here for cutting and sewing, the right-hand side states that maximum hours available is 900. For finishing, it's 300. And for packaging and shipping, it's only 100. As I mentioned earlier, are there only 3 constraints possible for this particular problem? There's a fourth one. And the fourth one pertains to the non-negativity, which means that in a production process, you cannot produce, if you produce nothing, which means zero, you cannot have less than 0 units. But if you don't specify that in your equation, Excel solver might give you a negative number, which is an impossibility. So we have to state that. So R and C is greater than equal to 0. So that would be your mathematical equation. The next part now is creating the spreadsheet model appropriate to solve, to identify your objective, which is to maximize profitability. Anyway, let's go back. So as I mentioned, so I've already created the first part, which is the parameter of the model. So let's open this. Okay. So as you can see here, the parameter consists of the given data based on the problem itself. So we've just translated it into a spreadsheet model. So you can see that it has similarities from the given problem, from the different processes, from cutting, sewing, finishing, and packaging and shipping, as well as the objective function here. And then you can see on the second column and third column is your decision variables, your regular and catch-ups model. As you can see here, we've included the hours or the numerical coefficient of your mathematical model. And on the third column is the available hours, meaning the constraints in terms of production hours. So it's 900, 300, and 100. So once you've created the parameter aspect, you're now going to create the model aspect. So key part in determining or creating your model is there are two parts that you need to identify quickly. So the first is, in terms of maximizing profit, is you need to determine the quantity. So quantity for how many regular versus catchers model you need to produce that would maximize profit, which is the next part. After you've identified the quantity, you need to determine the profit that you would generate from selling the said number of units. Now to determine that, we type in the function formula sum product and select the table array. So you need at least 2 to make this work. So you can do it in any order, but I prefer to highlight the quantity first, and then comma, highlight the profit for both regular and catcher. Obviously, your quantity right now is 0 units, so your profit is 0. But if you were to produce 1 unit of each, you will generate $13. If you produce more, 10 of each, you generate $30. And you can keep on doing this. But the problem here is you don't know what's the maximum that you can produce based on your limited constraints. This is where the second table comes in. So let's copy the processes again and paste it below. So we need to identify the available hours, which is already given. So I'm gonna go back. Okay. So you have the available hours given. So we need to determine the used hours. So to determine that, we'll use the same function as before using sum product. So sum product. So for the process, for the particular process in cutting and sewing, so we need to select the quantity first. Now we need to lock this, so select or press F4 to lock the cells, comma, and then select the parameter for your process on cutting and sewing. So to produce 10 regular and catchers, it would utilize 25 hours for cutting and sewing. And you can clearly see here that it does not exceed based on your available hours. So if you were to copy and do the same, again, select finishing 8 hours. So you can see here that based on the different processes, it utilizes different portions on the availability of your production hours. But what it tells you is does not exceed the available hours provided. So can you produce more? Yes. So the question is, what if we were to produce 100 of each unit? It's the result. So it does not exceed. So what if we were to produce 1,000 units of each? See what happens. So again, you generate more profit, but as you can clearly see here is the hours utilized is already exceeding the available hours. So which is big an impossibility unless you can add more hours. But based on the problem, you can do a trial and error and find out the optimal solution. But there's a better way. We can use Excel Solver to solve it for us. So simply select Data tab and select Solver. Now, to learn how to enable Excel Solver, you can check out my other videos. And once you've selected Solver, so a window will appear and asking you different aspects to determine the optimal solution. So for the first part here is by setting the objective. So it's selecting your profit. Second part is selecting to maximization. And by changing the cells, we're selecting the quantity for regular and catcher. Next is encoding the constraints. So select add. So this is where the constraints in your mathematical model comes in. So it's important to select to create a model properly so that once you encode it in Excel Solver, it will solve it automatically. If you create an improper model, mathematical model, you will get an improper outcome or solution. Anyway, so in our case, we have 4 constraints here, so we have to keep that in mind once we plug in our constraints. So you can clearly see here the 3 parts that you have to input. The left-hand side, the cell reference, next the inequality, and the third is the right-hand side, the constraints. And if you notice in your mathematical model, has those 3 components as well. So we just have to copy and paste the constraint. So for our left-hand side, so we select the hours used in our process for cutting and sewing. That's our first constraint. Then the second is our inequality. So for cutting and sewing, it's less than equal. Sorry, didn't select the hours used. So it's less than equal for our constraint. That's our right-hand side, so which is 900. So that's our first constraint. So to go to the next constraint, you simply select add. And for our second constraint, it's finishing. So we select used hours for finishing, which is 833. Then for inequality, it's still the same, less than equal. For our constraint, it's 300. And that's our second constraint. So let's go to the third one. So let's click add again. Select cell reference for use hours for packaging and shipping. Then for our inequality, it's still the same, less than equal. For our constraints, it's 100 hours. So we're done. So select OK. Now, if you notice here in our constraints, we've only encoded or input 3 constraints. But if you look in our mathematical model, we have 4. So how do we input the non-negativity? So simply check the box below that says make unconstrained variables non-negative. Okay. So next is select the solving method, which is simplex LP. That's so simple. And then select and click solve. Then it will automatically solve for you. So you can clearly see here the optimal solution here is to produce 500 regular and 150 catcher, and that would generate a profit of $3,700. Now to check if your answer is correct is by looking at the use hours in relation to the available hours. Did it exceed your constraint or available production? So for cutting and sewing, it does not. Actually, there's an excess or there's a slack or idle period of about 175. And then for finishing, it does not, as well as for packaging and shipping. So meaning it meets all the criteria, so it does not violate any of the constraints. So this is the best possible outcome. So let's go back here. So the main point of the solution here is just to give you an idea what the optimal solution here. Now, is it the best one? Not necessarily. Because you can think of different ways to achieve a better outcome, meaning maximize small profit. You can maybe add more hours to your production, but obviously you have to take into account the additional cost incurred, meaning in terms of salaries, as well as what do you call this, as well as utility costs that you have to pay. Another way is to simply increase the price, which would automatically generate more profit, but it's a sustainable decision. Maybe it would work, maybe it would not. So it's a big risk. And another is by adding or reducing the number of process hours involved for each production process. So reducing, let's say, the cutting and sewing process for regular and catcher, maybe that would increase your production capability and generate more profit. So there are different variety of ways. That's why spreadsheet modeling is a starting point for determining the best possible outcome. Similar to your project. So once you've solved the main problem, question is, can you come up with a better outcome? Okay. So let's take a look here. So are there any questions so far? Okay, don't see any questions so far. So let's continue with the next one. So let's take a look at our next problem. So let's go to the second problem. Okay. So here we have a problem on seawater restaurant. So they would like to determine the best way to allocate monthly advertising budget. So it's more on an advertising problem. So to identify, if you notice here, there's no more table below. So you have to read the problem or the situation carefully and go from there. So let's start from the beginning. So let's select the different parts. So the restaurant would like to determine the best way to allocate the monthly advertising budget of $1,000 between newspaper advertising and radio advertising. So, so that's the first criteria or constraint. And then second, management decides that at least 25% of the budget must be spent on each type of media. So that's another constraint. So let's select that one and choose a different color. Okay. And next, what do we have here? Next is the amount of money spent on local newspaper must be at least twice the amount spent on radio advertising. So let's select another color. Okay. Wait. There you go. So how many constraints do we have here? So let's see then the rest of the problem. So a marketing consultant developed an index that measures the audience exposure per dollar of advertising on a scale of 0 to 100, with higher values implying greater audience exposure. So the goal here is to maximize audience exposure. So with the value index for local newspaper is 50, and for index for radio advertising is 80. So that is our objective here. So for every local newspaper that we advertise, there's a exposure of 50, and for radio it's 80. So the question is, how should the restaurant allocate their advertising budget that would maximize audience exposure? Obviously, the objective is already identified here to maximize audience exposure. So we need to identify first what are the decision variables. So obviously, to maximize exposure, they're allocating their budget to two mediums, so newspaper advertising and radio advertising. So let's assign newspaper as N for newspaper and R for radio. So for the objective function here is based on the problem. So that's 50 N plus 80 R. Okay, that's correct. So next is identifying the different constraints. So based on the problem, we have, let's see, 1, 2, and 3. Okay, and there's a fourth one, as mentioned earlier, the non-negativity constraint. So for the first constraint, it says the budget allocation. So how do you allocate the budget? So you have to utilize both advertising, whether newspaper and advertising. So that's N plus R So the next question here is, what's our inequality? Will it be less than equal, less than, greater than equal, greater than, or equal to, or not equal to 1,000? So you have to read the statement carefully to give you an idea of what the inequality will be used. So allocate monthly advertising budget of 1,000. When you say of, doesn't say at least or maximum. When you say of, it's equal to. So to the amount of 1,000. So let's see if it's correct. That's right. So n plus r is equals to 1,000. So reading the statement is critical here to be able to do it correctly. Now for the second statement or second constraint, management decide at least 25% of the budget must be spent on each type. So there are two additional constraints. So constraint 2 and 3 will be pertaining to the minimum allocation of the budget. So you do it in any order. So n is greater than equal to, so 25% of the budget is 250. Okay, so that's for radio. And you can do the same for newspaper. N is greater than equal to 250. Let's see if it's correct. Yes, it is. So that's constraint 2 and 3. Now for our fourth constraint, the amount spent on local newspaper advertising must be spent at least twice the amount spent on radio advertising. This, if you read this, it seems a little bit tricky and confusing, but if you read it carefully, so you want to spend on local newspaper that is at least twice the amount spent on radio advertising. So the question is, which has the higher spending here? Is it local advertising or radio advertising? Which one's on the left and the right side? So local newspaper advertising is on your left hand side. So the question is, it says at least twice, so meaning it has to be greater than or equal to what's on your right hand side. So it says twice the amount of radio advertising. So twice the amount of radio. So that's 2R, 2 times R. Let's see if it's correct. And we're correct. So that's 2R here. And that's 4. Is it complete? Again, our last constraint you should always include is the non-negativity, wherein n and r is greater than or equal to 0. So that's our mathematical model. So now from here we can create our spreadsheet model. This one. Okay. So as I mentioned before, I've already created the parameter for this one. Let's check it one by one. It's correct. Okay. So based on our mathematical model, oops, sorry. So what's given here? Let me delete this one. Okay. So we have the objective function. So maximization of your audience exposure. So we have here audience exposure. So for newspaper, it's 50, and for radio, it's 80. So next is our constraint. So let's take a look here. So we have our budget allocation, which is 1,000. Okay. For our second constraint is our minimum spending for newspaper and radio. So that's for both. So 25% for newspaper, 25% for radio. Okay, and then newspaper has to spend at least twice the amount spent on radio. So that's for our constraint. So we already include all the parameters so far. So the next part now is creating the model aspect. So as for the model, we need to identify the budget allocation. So let's type in allocation. So allocation for your newspaper and radio advertising. And then next is identifying the maximum audience exposure. Okay, maximum audience exposure. Correct. Okay. So to determine again, we use the same function formula as before. We type in sum product, sorry, equals to sum product, and select allocation, comma, and select the audience exposure index for newspaper and radio. Now, obviously, there's no allocation so far, so our audience exposure is still 0. So let's go to the next one. So now we can start inputting our constraints. So let's go to Excel's data solver. So let's reset all the problem. So for our objectives, as mentioned, it's the audience exposure. And our objective here is to maximize, and then by changing the allocation for newspaper and radio. Now for our constraint here, so let's add, that's how many? That's 1, 2, 3, 4, and the fifth constraint. So for our first constraint, it says here that n plus r is equals to 1,000. So do we just simply select n, then plus r, then use the inequality equal to, and our constraint is 1,000. You can do that, but that would come out incorrectly once you run Excel solver. Instead, you have to add a third column in the problem. So you have to add a total amount wherein you use the formula sum to add the allocation for newspaper and radio. And that's where you will select for your first constraint. So let's repeat the process. So for our first constraint, so again, n plus r, okay? So that's our left-hand side. We select the sum or the total amount cell. And then our inequality, as mentioned, is equals to. And then for our constraint, that's our budget, which is 1,000. That's how you do it properly. So for our second constraint, we click add. So our left constraint, our left-hand side is n or newspaper, selects the newspaper ref cell. And our inequality is greater than equal. Let's change that. Then our constraint, our right-hand side is 250. So there are two ways of doing that. Either you type in 250 or you use 25% times 1,000. Okay, and select add. That's for newspaper. And do the same for radio. So radio is on your right-hand side, greater than equal, and your constraint is the same. So 25% times 1,000. And select add. So for our fourth and final constraint is newspaper. Okay. Then it says here greater than equal to 2 times the radio advertising. So to do that, we simply select. You can do it in either order. 2 times r or r times 2. It's the same. So try 2 times radio advertising and select OK. Now to check if you've done it correctly, so let's see how many constraints do we have in total. That's 1, 2, 3, 4, and 5. In here we have 1, 2, 3, 4. So our fifth constraint is by checking the non-negativity. So we've got the exact number of constraints. So let's select simplex LP and click solve. Okay, so let's take a look here. So we can see here that the maximum exposure is by reaching 60,000 people. So let's look at the allocation. So the total budget allocation is 1,000 and the newspaper allocation is $666, while radio is only $333. Now to check if your constraint is not violated, so let's take a look in our constraints in our mathematical model. So from our first model, it shows here n plus r is equals to 1,000. So it meets the criteria. And for our second constraint, where it shows newspaper, you have to allocate at least 250 of your budget, which is correct. So it's more than 250. For your radio, it's the same, more than 250. for a fourth constraint wherein newspaper has to be twice the amount, at least the same as twice the amount as your radio advertising. So your radio advertising is 333. If you multiply it by 2, or twice the amount, it's 666. So it meets all the criteria. And finally, is it non-negative? Yes, it is. So the objective here has been met by using 666 your budget to newspaper and radio 333 to reach as many people as can, 60,000 people. So again, the key to any spreadsheet model is the function of creating the appropriate spreadsheet model, mathematical model first, like this one, and identifying the objective constraint is critical. So understanding the objective of any problem and identify the different constraints or limitations of the problem. Yes, we have a question here. Hello. Yes, you still have to submit the soft copy of the assignment. So as for the soft copy, just type in the raw data in Excel and submit. So I can check and verify if your analysis is correct or not. I'll try to repeat the process. I'll try to show you the Excel solver. Okay, we'll use the problem here. I'll try to repeat the process. Okay, I'll go back. Let me see here. Where's my solver here? So let's repeat the process. So solver. So for a while, so let me try to add another one, another window. Solver. Yo. Okay. Let's put it there. Sorry for the confusion. I forgot to create another window for the solver window. I'll try to repeat the process again. Anyway, any questions so far regarding the process? So the key to any good spreadsheet model here is the mathematical equation, as I mentioned. That's why in your MGT, formulating the objective constraint is so critical, because one miscalculation or misinterpretation of the problem will have a detrimental effect whether you solve it manually or using Excel here. So, incorrect assumption on your inequality, like in the problem here. Let me go back to the window in this one. Let me hide this one first. Okay. So as I mentioned, in the particular constraint for the budget in the first one, as highlighted here, as I mentioned earlier, allocate the monthly advertising budget of 1,000 between newspaper advertising and radio advertising. So you can have different assumptions in terms of how do you allocate the budget. Do you use all of it, some of it, or none of it? Obviously, you want to utilize all of it, but with budget, you try to minimize your budget. You want to prolong your usage. So, but in this particular product, it states here that you have to utilize all of it. Obviously, it doesn't express it, but based on the statement, the budget of 1,000, it's assumed that you're going to use all 1,000 of it. Okay. So, anyway, let me repeat the process again. You're welcome, Miss Audrey. Anyway, so let me go back. Okay, so just to reiterate, so let's assume again, we've already inputted the parameters as mentioned earlier. So we're going to Excel Solver now. So if we go to Excel Solver, so select Solver. Okay, let me see if it pops up. Okay. So hopefully you can see it. Okay. Let me move it in my window so I can see clearly. Okay. Let me resize, it doesn't do that. Okay. So as you can clearly see here that the window in your solver has several aspects you need to fill in. So from the objective, identifying what your objective is, changing the variable cells, and inputting or encoding the different constraints. So let's do it one by one. So for our objective, typically this is your whether to maximize profit. In this case, our audience, wrong spelling. Sorry. Let me audience exposure. So let's go back. Okay, so for our set objective, that's our audience exposure or total exposure. Then second is to maximize. So how do we know that? Based on our mathematical model. Now next here is to choose the variables we want to change. In this case, we select the newspaper and radio allocation. So the tricky part here, as I mentioned from the beginning, is encoding or identifying the different constraints. And how do you make sure that you do it correctly? So you check and go back to your constraints, your mathematical model that you created previously. So let's try to do that. So let me move the window here. We can see if we've done it correctly. So minimize this. Oh, sorry. Oops. There you go. There you go. So we can all see the table. Okay. So to continue. So for our first constraint, as mentioned in the problem, so we need to, so the first constraint is regarding the budget. So normally, if you click add, where's the add? So let's add. So let's add another window. Oops. Sorry. Where's the window? Properties. Nope. Sorry. Not the window. What I was supposed to add. So we'll need to capture the where is it? I can't see the constant. For a while, I can't seem to find. There you go. The add constraint. So I can see here. So let me select this one. Ayun. Can you see the constraints? So if you notice, there is the left-hand side, the inequality, and the right-hand side. So what we have to do here is make sure that we follow the constraint based on our mathematical model. So for our left-hand side, it says that it's n plus r. So what you would normally do is simply select n. Sorry. Normally do is select the cell for newspaper and add r. But that's incorrect because it would you would incur an error in solver and solver cannot solve it for you. But instead of adding it, you create a third column as I mentioned, the total amount wherein you type in the formula sum and add the newspaper and radio allocation. So for your left-hand side, you simply select the total amount and select enter. And then you follow the same process mentioned before. So you select the inequality of equal. Then for your right-hand side, it says 1,000. So you select the parameter above and select 1,000. Okay. And select enter. Okay, so that's one. So for your second constraint, you select add. And again, so this is much easier. So you select N for your left-hand side, and then your inequality is, you change it to greater than equal. Then for your constraint, it mentions the minimum allocation of 250. So there are two ways of going about, as I mentioned earlier. Either you type in the amount 250, which is fine, or you could select the minimum allocation of 25% times your advertisement, which is 1,000. So either way is correct. Then you do the same for radio. So select radio in your left hand side, change your inequality to greater than equal. And then for your constraint on the right hand side, it's the same. So let's use 250 here. So that's 3 constraints down. For your fourth and final constraint, so you select the N again on your left hand side, then the inequality is greater than equal. Then for your constraint on the right hand side, so you could do it in any order, does not matter. It's either 2 times R or R times 2, does not matter. And select OK. So once you finish, you should go back to the main window, and you can see that all 4 constraints has been encoded. While your fifth is by checking your non-negativity. And again, as I mentioned, choose the method for simplex method and then select solve. Then you should have, sorry, the objective function is not selected. Okay, and then select solve. I deleted the formula, so see, I can make a mistake also. But I removed the formula, so it will not work. Then select the allocation and the audience exposure. Let's see if the formula is here. Formula is removed, so let me put it up. Then we can now redo it again. Solver, select solve, and voila. So again, to check or verify if you've done it correctly is by going one by one to the constraints. So for your budget allocation, were you able to maximize all of it? Yes, so that's one. For the second one and third one, minimum allocation 250, does it meet the criteria? Yes, it does. And then for the fourth one, is your allocation for newspaper is twice as much as your radio. So is 666 twice the amount for radio? Yes, it is. And is it non-negative, meaning more not negative values? Yes, it is. So the optimal solution is this one. So 666 for newspaper, 330 for radio, and the maximum audience exposure is 60,000. Now again, in any problem-solving scenario, in any situation, is this the best possible outcome? So the question you ask yourself, one might say, why not simply add more budget? But again, as in real life, budget is always limited and you cannot always get more. You may get more, but you go to a difficult process. So what else can you do to maximize audience exposure? Increasing the audience exposure index? Maybe you could do that. It's out of your control. How about using other mediums to reach your customers? So that's another way of looking about it. There are different ways to tackle a problem as long as you reach your goal, which is in this case to reach more customers so that more customers will know your restaurant and more will frequent your restaurant and will generate more profit. Okay? Was that better or clear to? Okay. Any questions so far? By the way, were you able to watch the start of the video regarding the discussion on our quiz 3, quiz 2, and our project? I mentioned earlier, let me go back to my cheat sheet. As I mentioned, quiz 2 result will be posted by tomorrow. I'll send everyone a link so you have a short window or a window between 1 to 3 to view it. So quiz 1, quiz 2 will be included there, plus the incentives, as I mentioned. So if you have any question, you can email me individually so that I can check and verify. And for quiz 2, as I mentioned, which will happen after the Holy Week, it depends. So I'm asking you as the audience or the viewers to give feedback. So if the topic is enough, If enough discussion has been already made, then we can proceed with our quiz. If not, we can discuss it further. What else? As mentioned, as for the assignment, uh, again, if you've already conducted the survey, you just have to uh, tabulate it and encode your raw data in Excel so that I can verify if your analysis is correct. So the raw data in Excel and the final paper will be submitted once classes resume. Okay? And then for the project presentation, again, now this is to prepare ourselves. So either way, in case should classes resume by after the whole week or whenever that may be, we have to prepare either way. So best case scenario is we have classes, we do the presentation, finish the semester. But worst case scenario, if we don't have the opportunity to have classes anymore, then maybe submission of final paper will suffice. But either way, you still have to create an output to be graded. Unless that changes, we'll wait and see depending on the situation. So I'll update everyone. Anyway, any questions so far? What else? So again, lifting of the suspension was scheduled to be after next week. So we'll see what happens. And depending on what the government does and what's the advice of the school, we will adjust accordingly. Okay. I think we can do one more problem before we conclude our session today. So, any questions from the viewers today? Let's see. So let's take a look here. Hope everyone's doing well. I know everyone's preoccupied with the current pandemic. Anyway, so let's do one more problem before we conclude our session today, unless there's more questions. Okay. So let's go here. So let's go to third problem here. So here the problem is on Blair and Rosen. They're a brokerage firm. Okay, that one. So it's an investment portfolio. So you're being asked to invest to help a client in terms of their investment. Okay. So let's read carefully. So specialized investment portfolio designed to meet specific risk tolerances for its clients. So a client who contacted the company has a maximum of 50,000 to invest. So they will advise the investor on in terms of what portfolio to invest. So they have two funds primarily, investment fund and blue chip fund. So it mentions here that the internet fund has a projected annual return of 12%, while the blue chip fund has a projected annual return of 9%. So let's highlight that first. So that's already our objective. So return, so annual return, so maximization. So let's read further. The investment advice requires that at most 35,000 of the client's funds should be invested in the internet fund. I think that's a constraint already. Let's see more. Okay. Then BR services include a risk rating for each investment alternative. So the investment fund, internet fund, sorry, which is more risky of the two investment alternative, has a risk rating of 6 per 1,000 invested. The blue chip has a risk rating of 4 per 1,000. So this is a risk rating scenario. Let's highlight that. Okay. Finally, BNR developed a questionnaire to measure each client's risk tolerance. So based on the response, each client is classified as conservative, moderate, or aggressive investor. So the current client is a moderate investor. Domestic client who is a moderate, limit is before. So there's a maximum risk rating of 240. So then highlight that one. So looking here, so based on the problem is what is the objective of the, okay, thanks for the feedback, guys. So going back, so based on the problem here, so your task to provide a recommendation in terms of how much to invest on a particular investment. In this case, we have two, blue chip and investment funds. So let's identify first the decision variable. So for purposes here, so to maximize our return, you have to invest on internet. So let's assign I for internet and for blue chip for B. Okay. Then for our objective function is to maximize our return. So that's internet is how many percent? 0.12 for, so 0.12 I plus 0.09 B. Okay. And then for our constraints, so we have to read carefully. So let's take a look at from the top. So what's the first constraint? So a client who has a maximum investment, maximum of 50,000 to invest. Okay. Okay. So let's highlight that. So you have to decide what's the best recourse. So how many constraints do we have so far? So the first is the available funds. Sorry. Second is the maximum allocation for internet fund, which is 35,000. And finally, the allocation of risk. Okay, so you have three main constraints mentioned here in the problem. So let's try to formulate it one by one. So for the first constraint, so how would you formulate that one? Okay. Anyone give me feedback as to how you would formulate the first problem? This is key. This is similar to the previous problem in the advertising problem. So how would you formulate the first constraint? So your total allocation, you use all of it, some of it, or none of it. So hint, the left hand side is I plus B. So the question is, what's your inequality here? So is it less than equal, less than, greater than equal to, or not equal to? Oh, there's a keyword mentioned here. I don't know if you saw it. It mentions a maximum. So a maximum of 35, maximum of 50,000. So you can reach up to 50,000, but you cannot exceed it. So it should be less than equal. Let's take a look if it's correct. Okay, that's right. So keyword here mentioned is maximum. So you can reach up to 50,000, but you cannot exceed beyond 50,000. Okay. So let's go to the next constraint. So as mentioned here, second constraint mentioned that the internet fund. Not that one. The investment allocation for internet fund is at most 35,000. So I is less than equal, greater than equal. So for at most, again, cannot exceed 35,000. So it should be less than equal to 35,000. So that's the maximum investment for internet fund. And then for our third and final constraint, mentioned about the risk involvement. So it mentions here that for every 1,000 invested, the risk rating is 6. For blue chip, for every 1,000 invested, it's 4. So how do you assign it? So that's 6I plus 4B. So what's the inequality? Is it greater than equal? Is it equal to, or not equal? So the maximum risk. Okay. So the maximum risk mentioned here is willing to take is up to 240. So it's less than equal. So 6I plus 4B is less than equal to 240. Let's see if it's correct. Okay, that's right. And then will be our non-negativity. So always remember the last, or the non-negativity constraint. It has to be less than equal. Cannot be greater than equal. If it says greater than equal, then it would only imply the minimum requirement. So if you said I plus B is greater than equal to 50,000, meaning the constraint is at least 50,000, you're investing at least 50,000 or more. But based on the problem, the maximum investment was up to 50,000, which is the complete opposite. So the inequality should be less than equal. So always keep that in mind so you don't confuse one over the other. Okay? So let's remove the cover here. So let's go to the constraints here. Let's create the spreadsheet now. So let's see. Let's open this. Oops, sorry. Okay. So if you notice here, I've illustrated the parameters. Let's see if we've done it correctly. So we've included all the parameters. So the first part is in our objective. So our annual return for internet fund is 12%. The for blue chip is 9%. Okay. And then next is our budget allocation. So if you notice, I've specified it's in thousands. That's why if you notice in the mathematical model, I only encoded 50, not 50,000. Then for the maximum investment, for the second constraint, maximum investment for internet fund is 35,000. So again, I have to forget to input. In thousand. Okay. And then for risk rating, so for every 1,000, that's 6 for internet, and for blue chip, it's 4. Then finally, the risk rating, the maximum risk rating that you're willing to take is 240. Okay, so that's all your parameters. So the key part now is creating the appropriate model. So select the model. Then allocation for internet and blue chip. Okay, so let's try to answer it one by one. So the next part here is not just the allocation, but also what's our objective, the annual return. So to do that, in dollars, thousands. So again, to determine the total annual return, we use the function formula again of sum product. We select the first table array of internet fund and blue chip, comma, and then the annual return percent for internet and blue chip. And select enter. Now, if you notice, we've only calculated for the annual return, but we also have to calculate for the risk, total risk incurred. So for the total risk rating, okay. Again, we do that by typing the function formula sum product. Then in this case, select again the amount to invest for internet and blue chip. For the other array, it's your risk rating per funds, which is 6 and 4. Okay, so let's try now to go to Exosolver. Okay, let's reset it again. Let's see if it's showing. Okay, let me adjust this. It's difficult to adjust this. There you go. Okay. So again, our objective here is to maximize annual returns, and then maximize by changing the variables in terms of allocation for internet and blue chip. Sorry. Okay, select enter. Now for the constraints. So again, check if how many constraints do we have here. So in our mathematical model, we have 4 constraints. So we have to make sure that we've encoded all 4 of them. So for our first constraint is the available investment funds. So that's I plus B doesn't equal to 50,000. So again, how do you go about inputting or encoding this in your left-hand step? Do you highlight internet plus blue chip cell, and then less than equal to 50,000? What do you think? Now, if you notice, it looks similar in our previous problem in the allocation of your budget, which means you have to create a third column, which is the total amount. So let's go back, close it first, and type in fund. Okay, and then type in the function formula sum and add the two funds. Then we can go create our first constraint. So let's go back to solver. For our first constraint, so the left hand side is I plus B, which is the sum. So we select total funds cell. Then our inequality is less than equal, so which is the same. Then for our available funds, which is 50,000, so we select that one. So that's our first constraint. For our second constraint, it's I. So internet fund is less than equal to, our constraint says here it's 35. So let's select 35 here. And then for our third and final constraint, it says 6I plus 4B. So where do we select that? Any guesses or ideas? So if you notice here, we created the total risk rating when we did the sum product. So if you notice 6I, meaning 6 times the investment fund, comma, 4 times the blue chip fund. So that's the cell you're going to select. So the total risk rating, in this case, less than equal, so it's still the same. And the maximum rating that you're willing to tolerate is 240. And select OK. So let's check. How many constraints have we encoded so far? That's 1, 2, 3. And then in our here, we have the fourth one, which is your non-negativity. So select LP again, simplex LP, and then click solve. Sorry, it's our objective. Let's select solve again. And voila. So we can clearly see here that to maximize our return with a total risk rating of 240, we should allocate 20,000 to internet fund and allocate 30,000 to your blue chip fund, which if you check, your allocation is 50,000. So let's double check if our constraints are violated or not. So for our first constraint, that the budget allocation or the investment fund in this case is up to 50,000, which is correct. Then for the internet fund with the maximum investment of 35,000, so it did not violate that as well. And for the third constraint, allocate the maximum risk for both funds is 240. So up to 40, which did not violate. So the annual return or total return based on the parameter or based on the optimal solution is 5,100. Okay. So the key here always is in your mathematical model or in the equation. Formulating it is so critical that one slight imperfection, meaning wrong assumption on quality or wrong variables, then you get a totally different answer altogether. Okay. So any questions so far? So we've already reached the 1 hour mark. So any questions so far? We have two more problems here, but we can finish here. Anyway, just to go over what we have discussed today. So the key part here is understanding the problem. What's the main objective? What are the different constraints? So you have to list up one item at a time and identify, does it mean, is it greater than, less than, or equal to? Because wrong assumption will lead to wrong path and wrong computation. So, any questions so far? Go back here. See not many viewers today. So for those who are joining in today, you can always go replay the video and watch from the very beginning. Okay? So what else? Any other questions so far? Don't see any. Thanks. Okay, Mr. Lance. How about the rest? Oh. So was it clear? I'm sure you have some. If you have lingering questions, now's the time to ask them because I know it's not the same as having a face-to-face interaction, but this is the best that I could come up with so that. Okay. Thank you for the feedback. By the way, do you have other classes ongoing right now? So why only if you are able to attend on the actual live stream? Okay, anyway. So can I get a feedback regarding should we extend to another live stream in the future so that I can show you more examples on how to utilize linear programming using Excel. Actually, I haven't even discussed linear programming, which is another variation of linear programming. You just have to add one more constraint. It's very easy. We have the time. Yes. So just to go over, so please tell your classmates regarding what we discussed today, especially the quiz 2 results. So again, as I mentioned, I'll be posting the link later so you can view it by tomorrow. So you have a window from 1 to 3 p.m. So you can check them if there's any questions or clarifications, and feel free to email me. For quiz 3, which is tentative, so our target date is by next week. So I'm still waiting feedback from everyone whether we need to add one more session or streams in this case to discuss further on linear programming. Otherwise, we can have quiz 3 so that at least you'll be able to finish all the topics. So you just have to focus more on the project presentation. Now, as I mentioned before, at the start of the stream, for the project presentation, the key here is not just finding the solution. The solution is just the initial part. So for example, like in the examples provided here earlier, so what do you do? How do you come up with a better model, better outcome? So whether maximizing profit, maximizing audience exposure, or minimizing cost. So you have to think outside of the box and come up with a better solution now. You can talk over with your other group mates and think and find different ways to achieve a better outcome. Hopefully you can come up with a unique solution, which is something that you would be surprised that you have in your arsenal. Okay? If there's no more questions, you can end the live stream. So don't forget to leave a comment down below and hit the like button. So for more videos, live stream, you can check out my other videos. Thanks for watching. I'll see everyone on the next stream. Stay safe. By the way, enjoy the rest of the week. Happy Easter to everyone. You're welcome, everyone.